All right, you guys, as we continue our discussion about functions, we've approached our next concept, which is the difference quotient, okay? Now, the difference quotient is an important concept in calculus, and it involves looking at a certain quotient, okay? Quotient means to divide two quantities, okay? So for a given function, y equals f of x, the inputs x and x plus h, where h does not equal 0, result in the images of f of x and f of x plus h. The quotient of their differences comes out to this, which we call the difference quotient, which is f of x plus h minus f of x over h, okay? Now, this definition has this restriction where h cannot equal 0 because this is a rational, which means that it looks like a fraction. Since it looks like a fraction, it behaves like a fraction. And the only number we can't divide by is 0. So that is why there is this restriction where h cannot equal 0. Okay? So for those of you that plan on going on to calculus, you will use this in the future because that's how we derive the definition of a derivative. Okay, and we use derivatives when we're talking about things like velocity of an object and optimization of resources. Okay, but for us, we're not going to go that deep. We just need to know how to simplify a difference quotient, or I've abbreviated it as DQ. Okay, so you know when you are done with these problems, because our goal is going to be to simplify this expression such that the h in the denominator cancels out. Okay, so we're going to do a couple of examples so you guys get used to using this formula and simplifying it. Okay, all right, so let's look at this problem. It says find the difference quotient of the following function. F of x equals 2x squared minus 3x. Okay, so when you're using the difference quotient, okay, you have to first know what the difference quotient formula is. And it's always going to be f of x plus h minus f of x all over h, okay? Now, you can think about this like a recipe, okay? In order to calculate this, you have to know what f of x plus h is, you have to know what f of x is, and you have to put it all over h, okay? So our particular function this time is 2x squared minus 3x. So what I like to do, I like to figure out what f of x plus h is before I try to plug it into this function, okay? So I've done that over here on the side in blue. So I have to do f of x plus h, and this notation tells me everywhere in my function where I have an x, I'm going to replace it with x plus h, okay? So my function was 2x. Instead of this x, I'm putting x plus h squared minus 3. There's another x. I'm replacing it with x plus h, okay? Now, once I've made that replacement, I can go ahead and simplify this, okay? So this x plus h squared, that's a quantity squared. So in order to multiply that out, I'm going to have to use FOIL. I've done that already, and I've put it here in the parentheses. It's given me x squared plus 2xh plus h squared. And then I'm going to bring down that 2 that sits in front of that parentheses. And then for the second part, I'm going to distribute this negative 3 to both of the terms that fall behind it. That's how I get negative 3x minus 3h. Okay. Now I'm going to distribute the 2 to everything that's in the parentheses. Okay. And bring down this last part of this equation. Okay. So I've completely found f of x plus h. So I have the first part of this formula. Okay. I don't have to do anything to get the second part. This is just f of x. That's the definition that they gave me. All right, so I'm going to plug that in, and then I'm going to put everything over h. So you'll see that here in the purple. Okay, so this part is my f of x plus h minus my f of x all over h. Okay, now once I've done this, I need to simplify this because remember the goal is to cancel out this h in the denominator. Okay. So the first thing that I do is I distribute this negative sign to all the terms that come behind it. So you'll notice here in the second line, my signs have changed on these two terms, okay? And then I'm going to cancel out any like terms. So you'll see that my 2x squares and my 3x's, they cancel, okay? So I write what's left, all right? Then I notice that, okay, in my numerator, my GCF, if you guys remember what GCF stands for, it stands for greatest common factor. So each one of these terms in my numerator, I can factor out an h, okay? When I do that, it leaves me with 4x plus 2h minus 3. And since I factored out this h now, this h will cancel with the denominator, which is our goal. I know that I'm finished when I can get rid of the h in the bottom. And so my answer is what remains, which is 4x plus 2h minus 3. Okay? So one thing I will stress about these problems is make sure that you stay organized, okay? And make sure that you are careful with your multiplication because there could be a lot of sign changes like we saw here, okay? Another thing I want you to do in your notes, take note of what type of function this is, okay? This particular type of function is a polynomial function, which means it has multiple or many terms. Nothing in here looks like a fraction, and nothing in here has a radical symbol in it, okay? Anytime you have a difference quotient problem and it's a polynomial, it's going to look something similar to this one, okay? So if you just want to write that down in your notes, just keep track of that, okay? All right, let's try another example. All right, so same directions. So find the difference quotient of the following function. And this time our function is 4x equals, f of x equals 4 over x, okay? So we're going to use our same formula again, okay? And for me, I always like to figure out what f of x plus h is over here on the side. So I've written it over there in blue. Unlike the last one, there's nothing I can do to simplify this any farther, but it's nice to have it over there so I know what it is, okay? So remember, you don't have to do anything else to find f of x. They always have to give that to you. And once I have these two parts in the numerator, I need to put everything over h, okay? So that's what I've done here in the purple. I've written 4 over x plus h minus 4 over x all over h, okay? Now remember, you're done with these problems when you can completely cancel out the h in the denominator. The way that this problem is written now, there's nothing else that I can do to simplify it the way that it's written. So my best bet is to try to simplify the numerator. So in the numerator, I have two fractions, okay, and I'm subtracting them. The only way that you can combine fractions is if you have a common denominator. So in the green, you'll see that I'm multiplying each one of those expressions by what they're missing. So the first expression I multiply by x, top and bottom. The second expression I multiply by x plus h, top and bottom, okay? I multiply across. So you'll see now that that first expression becomes 4x over x times x plus h, and that second expression becomes 4 times x plus h all over x times x plus h, okay? Since in the numerator I have one common denominator now, I can combine the numerators. I've distributed the negative 4 to both the x and the h to get this, okay? And then now I can combine like terms. So in the numerator here, you see I have positive 4x minus 4x. Those are going to cancel, which just leaves me with negative 4h all over everything else that I had, okay? Now, this is a complex fraction, which means that I have a fraction sitting inside of a fraction. So in order to simplify that, I can do keep, change, flip, which is multiplying by the reciprocal. So instead of dividing by h, I can multiply by 1 over h, which is the reciprocal. When I do that, the h's cancel because I have 1 in the numerator and I have 1 in the denominator. So my h's are gone and I can multiply straight across. Numerator times numerator, denominator times denominator. So that leaves me with negative 4 over x times x plus h, okay? Now, like I told you before, to make note, when you look at this function here, okay, the type of function that this is, it's a rational, okay? It looks like a fraction. So anytime you have a difference quotient problem that involves a rational, your steps are going to look something similar like this. You're probably going to have an expression where you're going to have to find a common denominator, and you're going to have to simplify it, and then towards the end, you're probably going to have to multiply by the reciprocal or keep, change, flip. Okay, so just kind of keep that rhythm in your head depending on what kind of function that you've been given. Okay, now I want to do one more of these with you. So let's go to the next one. Okay, so same directions, find the difference quotient of the following function, but this time we've been given f of x equals square root of x. So I'm going to set it up just like I did before. Okay, my difference quotient formula has not changed. It's still f of x plus h minus f of x all over h. And over here to the side, I'm always going to figure out what f of x plus h is first. So that means that everywhere in this function where I saw an x, I'm going to replace it with x plus h, which gives me the square root of x plus h. Okay. Now I have everything that I need to plug into the formula. So I plug in the f of x plus h part minus f of x, which is the definition that they gave me, square root of x, all over h. Okay. Now remember, the goal is to eliminate or cancel out the h that's in the denominator. The way that this is written now, there's nothing that cancels. Okay. So the trick to these problems are you are going to rationalize the numerator by the conjugate. Okay. So what a conjugate is, it's a binomial term, so it has two terms, and whatever you start with, it has the same front term and back term, but opposite sign of what you started with. So here I have the square root of x plus h minus the square root of x. So if I rationalize this using the conjugate, my front and back terms stay the same, as you can see here in the green, but my sign is the opposite of the one I started with. So because my two terms have a minus in between them, I'm going to rationalize this using two terms that have a plus in between. Okay. Now I'm going to multiply this together. So you have two terms here and you have two terms here. So you're going to FOIL it. So you're going to do first terms together. So the square root of x plus h times the square root of x plus h. The radicals are going to cancel. You're going to be left with what's underneath, which is just x plus h. Okay. Now the cool thing is because you are FOILing conjugates, the O and the I of FOIL is always going to cancel. So if you notice that, you don't have to do the O and the I for outside and inside. You can just go straight to the L, which are the last terms. If you do it, no worries, you'll see that the terms are going to cancel, okay? But for me, I'm going to skip the O and the I because I realize that they're conjugates. So I'm going to multiply the last terms together. So I have negative square root of x times positive square root of x. When I multiply them together, the radicals cancel, but this is negative, so it's going to give me negative x all over the denominators. So I'm just going to push everything together. X times the square root of x plus h plus the square root of x. Okay. Now, in the numerator, do you see that one of your x's is positive and one is negative? So they're going to cancel. So that's going to leave me with h in the top over the denominator. And then my h's can also cancel because I have one in the numerator, one in the denominator. So that's going to leave me with 1 over the square root of x plus h plus the square root of x. Okay. Now I know this might send off some alarms in your head because you're used to, well, Miss Thomas, we can't leave the radical in the denominator. Well, actually, for your difference quotient, these are the only problems where you can. It's totally legal. So the reason why you can leave it like this is because if we rationalize this again, it's going to give us back what we originally had, which will undo it. So we're perfectly fine. You can leave it like this. Okay? Cool. I hope this helps.